Hello students, today we are going to study system of linear equations in numerical methods. In this linear system of equation, how to solve these by using some direct methods and iterative methods. Let's start with the notations and definitions. A journal linear system of n equations in n variables can be written as the follows. This type of equations like a11, a12, x2, a1 n xn is equals to b1 and so on. हमने n equations ले ली हैं जहाँ पे आपके पास elements आ रहे हैं, coefficients आ रहे हैं x1, x2 up to xn के. In this notation, the variables are denoted by x1, x2, xn, and sometimes we also write xi, which is I varies from where I varies from 1, 2, 3 up to n to represent the different variables. The coefficients of variables in this system of equation can be written in the matrix form known as coefficient matrix. This is called coefficient matrix. So the coefficient matrix corresponding to system of equations 1 is given by this capital A, the coefficients of x1, x2 and xn up to all these terms, and we use the notation aij, this aij, to denote the coefficient of xj in the ith equation, which occurs in the ith row and jth column of the coefficient matrix. The numbers on the right hand side of this system of equations are called constants and are written usually in the column vector form, and this is called constant vector. The coefficient matrix may be combined with the column vector capital B to form the augmented matrix. This augmented matrix जो आपने matrices में पढ़ी है अपने lower standards में, तो augmented matrix A, B, where all the elements of A and then elements of B, that is the constant vector. Further, if all the numbers occurring in the right hand side of the above system of equations are 0, that is bi is equals to 0, I means I 1, 2, 3 and तक जितना आपके पास जा रहा है, then the system is called homogeneous system of equations. If at least one out of b1, b2, bn is non-zero, then system is called non-homogeneous. Okay, so this is called non-homogeneous if any one of them is not equal to 0. If all are 0, then we say it is homogeneous system of equations. Next we study about the existence of solution. By solution of system we mean the determination of a set of values x1, x2 up to xn which satisfies each of the equations, these equations. Okay, that is if the values x1, x2, xn satisfy all the equations simultaneously, then the set x1, x2, xn constitute a solution of the system. For a particular system of n equations, there may be a single solution or no solution or infinitely number of solution. Now let's see how to define this. A system of n linear equations in n variables with coefficient matrix capital A and constant vector B which is not equal to 0 has a unique solution if and only if the determinant of A is non-zero. ये आपने पहले भी स्टडी किया हुआ है इन लीनियर सिस्टम ऑफ इक्वेशन जहाँ पे आपने मैट्रिसेस से भी सॉल्व करी हुई है वो इक्वेशंस. तो यहाँ पर हमारे पास अगर A determinant is non-zero है, then we say it is a unique solution. Second, if B is equals to 0, then system has trivial solution or zero solution. Further, in this case, if determinant of A is 0, then the system has an infinitely number of different solutions. Otherwise, the system has no solution than the trivial solution. Okay. Now, here the solution of linear system, we study some direct methods and iterative methods. So the direct methods we are going to study is Gauss Elimination method, Gauss-Jordan method, Crowd's method, Kolesky method. Iterative methods are Jacobi's method, Gauss-Seidel method, and SOR iterative method. Let's study about the first direct method, Gauss Elimination method. In this method, the unknowns are eliminated by combining equations such that the n equations in n unknowns are reduced to an equivalent upper triangular system, which is solved by back substitution method. You have already studied in your lower standards the upper triangular system क्या होता है and what is the back substitution, but I will revise it here. Let us consider 3x3 system where these three equations are given with these coefficients and constant vectors. Now first we do the triangularization, in which to eliminate the coefficients a21, this a21, and a31, this a31, using first equation from the system of equations, which is this equation 1. For this we subtract from second equation, this second equation से हम subtract करेंगे by a21 over a11 times the first equation, multiply first equation, and subtract from third equation a31 over a11 times the first equation, so that the given linear system is transformed to following equivalent system. These, ठीक है, हमने फर्स्ट इक्वेशन को मल्टीप्लाई किया a21 over a11 से, and then we subtracted from second equation of this, and then we multiply a31 equation 1 से, and then we subtracted from the third one, and after that the subtraction we obtain this condition. Okay, then again we have to form the upper triangular matrix, so we have to also again do the same process with the left linear system of equations. The numbers a21 over a11 and a31 over a11 are called multipliers for the same first stage. In this stage we have assumed that a11 is not equal to 0. Next we eliminate the coefficient a32 dash, this one a32 dash, ताकि ये upper triangular matrix बन जाए. तो इसके लिए हमें क्या करना पड़ेगा, we have to eliminate a32 dash times, then what we do that eliminate the coefficient a32 dash using second equation from the system of equations 2. For this subtract from the third equation, this third equation, subtract third equation. हम क्या करेंगे, a32 dash over a22 dash, this a32 dash over a22 dash times the second equation, so that the system of equations 2 is transformed to the following this one. हमने a32 dash a22 dash जो यहाँ पर आया है इसको आपने मल्टीप्लाई करवाया और यहाँ से सब्ट्रैक्ट करवा दिया, थर्ड इक्वेशन से सब्ट्रैक्ट करवा दिया, और इस स्टेज पे हमने ये अज्यूम किया कि a22 dash is not equal to 0. Also the second equation is called this one. This is called multipliers of the second stage with assumption that a22 dash is not equal to 0, and also the second equation is called pivotal equation. This equation जो अभी हमने किया pivotal equation, this is the pivotal equation, and a22 dash is also called second pivot for the stage second. a22 dash is second pivot. First pivot was these elements, and for second, this is the second elements, this is the first pivot element and the second pivot element. Therefore if we apply back substitution we get the upper triangular system of equations. अब आपके पास upper triangular form में आ गया है, and from this we can find the value of x3, x2 and x1 by using back substitution, this x3, x2 and x1. Let's understand this by the help of question. Before this, first we understood the concept of pivoting. Here, let's see how do we do pivoting. If a pivot element is very small compared with the elements in its column which have to be eliminated, the corresponding multipliers used at that stage will be greater than 1 in magnitude. The use of large multipliers in the elimination and back substitution process leads to magnification of round-off errors. Also, the method fails if the pivot element at any stage becomes 0. The build-up of round-off errors or getting the pivot element as 0 may be avoided by rearranging the remaining rows. This strategy is called pivoting. The pivoting is of two types: partial pivoting and complete pivoting. In partial pivoting, the first stage of elimination, we search the first column for the largest element in absolute value and interchange the first equation with that having the largest element in absolute value. The new first pivot element is larger in absolute value than any element beneath it in its column. In the second stage of elimination, we search the second column for the largest element in absolute value among the n-1 elements, leaving the first element and interchange the second equation with that having the largest element in absolute value. The second pivot larger in absolute value than any element beneath in its column. This procedure is repeated until we get an equivalent upper triangular system of equations. This procedure is called partial pivoting or partial condensation. Now, complete pivoting. In this procedure, we search the coefficient matrix A for the largest element in absolute value and bring it as the first pivot. This procedure not only requires an interchange of equations but also an interchange of the position of variables. This procedure is a little bit complicated and does not appreciably improve the accuracy. Let's start with the question. First, 3x plus 4y plus 5z is equals to 40, 2x minus 3y plus 4z is equals to 13, x plus 5 plus z is equals to 9. It's given. We have to find the value of x, y and z by using Gauss Elimination method. So, Gauss Elimination method में हम क्या करेंगे? First we eliminate x from second and third equation. For this we multiply equation 1, a, b, c, a by 2 by 3 and subtract from b 1 by 3 से multiply किया equation a को and then subtract from c. Let's see what happened. After multiplying 2 by 3 with equation a, आपके पास क्या आएगा? 2 by 3 into 3x plus 2 by 3 plus 2 by 3 is equals to 2 by 3, 40. So we get this 2x plus 8 by 3y 10 3z is equals to 80 by 3. So we get 2x plus 8 by 3y plus 10 3z is equals to 80 by 3, and then subtract it from 2x minus 3y plus 4z is equals to 13, this b. After subtracting we get this equation. Now for the second one, 1 by 3a, we multiply 1 by 3 by first a equation and then we get the equation converted to this one. Then we subtract it from the c equation. Then we get minus 1 by 3y, minus 2 by 3z and minus 13 by 3 by subtracting it from c. Now we do the second stage. Second stage, we eliminate the value of y from the third equation of system of equation this. So the exact equations what we get are these equations, and we have to subtract y from this third one. To subtract this one, we again multiply the second equation by 1 by 17. Multiply equation second by 1 by 17 and subtract from third equation, this third equation, subtract from third equation. We get, after multiplying with 1 by 17 to the second equation, we get this equation, minus 1 by 3 y plus 251 z is equals to minus 41 51. Then we subtract this from third equation, which is minus 1 by 3 y minus 2 by 3 z minus 1 by 3 y plus 2 by 51 z is equals to 41 by 3 minus 41 by 51. So minus 1 by 3y minus 1 by 3y get cancelled, and then we left with minus 12 by 17z is equals to minus 180 by 51. Now hence we apply the back substitution. तो हमारे पास डायरेक्ट वैल्यू z की आ जाएगी, तो हम डायरेक्ट वैल्यू लिख सकते हैं z इज इक्वल्स टू माइनस 180 बाई minus 12 into 17 by 51, which is on solving we'll get is equal to 5. And then from second equation of system of equation 3 जो हमने अभी निकाली थी, that is minus 17 by 3y plus 2 by 3z is equals to minus 41 by 3. After substituting the value of z, we get 5 is equals to minus 41 by 3, which implies y is equals to 3, and using the value of y and z here, z is equals to 5, in equation number 1 we get 3x plus 4y plus 5z is equals to 40. जो हमारी फर्स्ट इक्वेशन है, it gives value 3x plus 4 3 plus 5 is 40, which gives the value of x is equals to 1 after solving. Hence the solution is x is equals to 1, y is equals to 3, and z is equals to 5. Now let's do the second question. 3x1 plus 6x2 plus x3 is equals to 16. ये तीन equations आपको दी है. We have to solve it by Gauss Elimination method. First we do the triangularization. For triangularization, we eliminate x1 from second and third equation by simple subtracting equation 1 after multiplying with 2 by 3 and 1 by 3, and then subtract it from second and third equation. Let's see. We multiply the first equation by 2 by 3. We get, then subtracted from 2x1 plus 4x2 plus 3x3 is equals to 13. 2x1 plus 4x2 plus 2 by 3x3 is equals to 32 by 3. Minus we get cancelled with this, and 7 by 3x3 after subtraction, and we get 7 by 3, which implies हमारे पास वैल्यू आ जाएगी डायरेक्ट ही यहाँ से 7 by 3x3. सो बट हम सेकेंड वाले को भी ट्राई करेंगे. तो अब आपके पास क्या है, वी मल्टीप्लाई द इक्वेशन 1 by 1 by 3. फॉर गेटिंग द थर्ड इक्वेशन we get 1 by 3, 3x1, 6x2, x3 is equals to 16, which gives x1, 2x2, x3 by 3 and 16 by 3. Now we have to subtract this equation from third one, which is x1 plus 3x2, 2x3 is equals to 9 minus x1 plus 2x2 plus x3 by 3 and 16 by 3. Minus, minus and minus. So the final answer is, we get cancel this, and then we get x2 plus 5 by 3 x3, and this is 11 by 3. So after doing this first stage, we get equations 3x1 plus 6x2 plus x3 is equals to 16. 7 by 3 x3 is equals to 7 by 3. x2 plus 5 by 3 x3 is equals to 11 by 3. But here the second equation, in second equation the pivot element is 0. Here no pivot element, so we cannot proceed as usual. So we interchange second and third equation. Okay, then we have to interchange the second and third equation for upper triangular linear system of equations. So we write it like x3 is equals to 11 by 3 and 7 by 3 x3 is equals to 7 by 3. Now by using back substitution method you can easily find the solution. यहाँ से तो x3 directly आ रहा है, which is equal to 1. Substituting the value of x3 in this equation, we get x2 is equals to 2, and after that using this x3 and x2 from equation number 1, that is 3x1 plus 6x2 plus x3 is equals to 16, we get 3x1 plus 6x2 plus 1 is equals to 16. This will get the value of 16 minus 13, which is equals to 16 minus 14 is, we get x1 is equals to 3 by 3, which is 1. So we get x1 is equals to 1, x2 is equals to 2 and x3 is equals to 1. So practice more questions of this type.